In this video, we're going to be rationalizing radical expressions, specifically with radicals in the denominator. We need to rationalize these because you cannot leave a radical in a denominator. So if we look at example A, we see 5 divided by 2 times the square root of 3. The 2 is fine. It's the square root of 3 that can't be there. So what we want to do is we want to multiply both the denominator and the numerator by the square root of 3. So on the top, that's going to give us 5 times the square root of 3. And in the denominator, that's going to give us a 2 times the square root of 3 times the square root of 3. Now we know that the square root of 3 times the square root of 3 makes the square root of 9. So what we're really looking at here is 5 times the square root of 3 in the numerator times 2, or over rather, 2 times, and the question is, what is the square root of 9? And the square root of 9 is 3. So we're going to plug a 3 in there. So that's going to give us 5 times the square root of 3 over 6. And we see that we do not have a radical in our denominator, and everything is simplified, and so we're finished. Now, a little shortcut that you can do is that if I have a square root, like I do here, that means that I need 2 radical 3's to make it go away. So basically, by saying that I have the 2 radical 3's here and here, I can take away my radical and just write the 3. So I could have just skipped all the way to go 5 radical 3 over 2 times 3 and then gotten my answer as well. I could have done that too. Okay, so that would have been another way, a little bit faster to get there. I'm going to erase that so that we have a little bit more room, and we're going to look at problem B. So problem B says 2 divided by the cubed root of 5, and we can't have the cubed root of 5 there, so no radicals. So here we have a cubed root of 5, which means I need 3 radical 5's. So I'm going to multiply by 2 more radical 5's. That way I have the 1, 2, 3 that I need to make that radical sign go away. Now remember, whatever you multiply the denominator by, you also have to multiply the numerator by. So remembering that if we needed 3, and we now have 3, that we can take away the radical and just write 5. I'm able to just put my 5 there. And on the top, I will have 2 times the square root of, and 5 times 5 is 25. Except we weren't multiplying by square roots. We were multiplying by cubed roots. So it's important that you remember to take the roots with you. Because if you don't, you're going to end up with an incorrect answer. Because if we had left that as 2 times the square root of 25 over 5, we would have simplified that even farther to 2 times 5 over 5, or 10 over 5, which equals 2, and that would have been completely wrong. So it's important to make sure that you're taking the symbols with you. Now take them with you when you do your multiplying. But now we can't simplify the 2 and the 5 anymore, and we can't simplify the cubed root of 25 either, which means that we are finished, and this is a simplified expression. So let's take a look at problem C, because this one's a little bit more difficult because it's got this plus sign right here. So when it has a plus sign like that, that means that you kind of have an extra step. You're going to do something, multiply by something we call the conjugate. Let's make some room here. The conjugate. So the conjugate is like a matching opposite. So what that means is that if I have a 3 plus the square root of 7, its conjugate would be a 3, let's use a different color to indicate that, would be a 3 minus the square root of 7. notice that the 3 and the square root of 7 are the same, but our symbol between them is different, hence a matching opposite. So if we come back over to our problem, we're going to end up multiplying both the denominator and the numerator by the conjugate, which we found to be 3 minus the square root of 7. Now, as far as the numerator goes, because it's just a single digit of 2, we're able to just distribute. And 2 times 3 is 6. The minus sign will stay there. And then we'll be left with a 2 radical 7. Because the 2 is on the outside and the 7 is on the inside, they can't go together. Now, to multiply by the conjugates, it's a little bit messier. Now, you could distribute or do something called foiling, or there's a shortcut. We're going to take the shortcut. So the shortcut says that when you multiply two conjugates, or conjugates rather, that you can do a little equation called a squared minus b squared. Now in this situation, our a squared, our a value, is the first piece, and our b value is this second piece right here. So if that's the case, and this is our a value, and this is our b value, so we can plug those in. 3 squared minus the square root of 7 squared, and we know that 3 squared is 9, minus, and from our properties of radicals, we know that if we have a radical 7 and we're squaring it, the radical and the 2 cancel out, dropping down just a 7. And 9 minus 7 is 2. And so we're able to take that 2 and put it over here. And then depending on how simplified your teacher wants it, you might be able to leave it like this. If not, what you need to understand is that because the 2 can go into 6 and that leading 2, right, we're able to simplify this farther. We can write it a little bit simply, like we're going to have 6 divided by 2 minus 2 radical 7 over 2. And this might be a step right here that you don't necessarily need to write down, but I want you to see the thought process. Okay, so what is 6 divided by 2? How does that read? Well, 2 goes into itself one time and into 6 3 times, so we'll have a 3 minus, and 2 goes into itself one time and into itself one time, leaving us with just a radical 7. So we end up having a final answer of 3 minus radical 7. So again, you'll just need to check and see how far you need to simplify it to see if this is something you can leave it as, or if you need to take it all the way down to fully simplified.